Today, I'm your guest lecturer. My name is Volkan Gazioğlu. I will share my PPT screen right now, just a minute. I'm using LibreOffice, an open source office software, maybe you know. All right, I think you can see my PPT screen. This is first screen. This is COE 308 Programming Language course, week 13. The lucky number is for me, Asynchronous Programming. One of the most important topics nowadays, very popular topic, asynchronous programming, especially in modern language. Most of the coders want to learn how to make effective asynchronous programming, what are the ins, outs, internals of asynchronous programming, and there's a lot of confusion on asynchronous programming. I think I will help you in this session to learn about the issues, the topic deeply. Your course lecturer is Ahmet Feyzi Ateş, is my very old colleague and my good friend. He's from Southern California University and also from Japan, Aizu University. And I am, as I said, Volkan Gazioğlu, Technology CEO of Arma Group Holding. If you want to learn about me, you can go to www.gazioğlu.com, and in the screen, you can see my LinkedIn, Twitter, YouTube, and Medium topics. I write some articles in Medium.com. I think you can enjoy my articles in various topics, especially in technology and foreign politics and defense. In this course, what is our objective? What are our objectives? After completing this course, you will be able to have a general understanding of what is concurrency. What kind of concurrency types are there? What is the difference of concurrency with parallelism? What is asynchronous programming? And we will make a call that in Dart language, a very famous, very popular Dart, very popular programming language, especially used with Flutter framework, a cross-platform framework, maybe most of you know. And what is the difference between synchronous programming and asynchronous programming? Also, we will talk about some keywords, topics, including process, thread, coroutine, task, time slicing, multi-programming, multi-processing, future promise, isolate, async, await. And I will share some programming history, since I'm a bit old guy. Maybe we will have a look to the old days of concurrent programming. Okay, let's start. As far as I know, I remember also from my university days, there are too much confusion on some keywords, buzzwords, some topics on synchronous, asynchronous, multi-threading, multi-programming, multi-processing, distributed processing, concurrency, parallelism. Especially the topic is very simple, but when we try to implement those features in our daily life, in our business life, it becomes a bit complicated. But don't worry, after this course, I am sure you will be able to very good understanding. You will have a very good understanding of those topics and implement those topics in your business life and your university life. Everybody knows nowadays there is a bottleneck on microchips. Automotive industry experiencing hardness just because of this, and microchips are becoming expensive, more expensive every day. What do you think your fancy X-brand expensive CPU does most of the time? Have you ever inspected your operating system's task manager? Is it always working? No, most of the time it's idle. So this means you are wasting your money, huh? The concurrency topic is actually based on this issue, money. You buy an expensive CPU and you don't want it to be idle, especially for some blocking operations, for some disk reading, writing, I/O, we say, and some networking operations. There's a table on the screen, maybe you can see latency versus system event. CPU cycle, L1 cache access, L3 cache access, memory RAM to the network to Tokyo networking event. You know, CPUs are not, I am talking about a one-core CPU, are not parallel. A CPU can execute an instruction every 1 nanosecond approximately. This depends on the technology of CPU, of course. Let's say you are making a networking activity. You are in New York City and you are making a request to a website in Tokyo. According to the graphic chart on the screen, you waste approximately 348 million cycles for it come back. This is the issue, but not everything is lost. You can use that time to perform other tasks if you use a non-blocking, we say asynchronous code in your programs. But don't worry, actually, operating system codes and most of the codes are written in asynchronous fashion. So we are not wasting our valuable CPU time. And there's a bit multitasking video on the screen, maybe you didn't see. I will share my presentation after this course. You can use it as a reference also for your future work. Let's minimize this. All right, let's continue. By the way, before the course, I tried to examine, try to understand the etymology of synchronous word, and I went to Oxford Language Dictionary. The word comes from Old Greek words from sun, together, and chronos, time, and sun chronos, and in adding the English suffix us, it becomes synchronous. But this word is also a bit confusing. Remember this after learning what is concurrency, what is synchronous and asynchronous. You will also notice there is also confusion, the origin of the word, the meaning of the word, and what we use in our computing life. What is concurrency? Concurrency is when two or more tasks can start, run, and complete in overlapping time periods. It doesn't necessarily mean they will ever both run at the same instant. For example, multitasking on a single core machine or on a single CPU machine. Remember, concurrency is when two or more tasks can start, run, and complete in overlapping time periods. Maybe you remember in your operating system courses, processes are operating system level execution context, but threads are sub-process execution context. Threads are much lighter in weight than processes. That's why most of the programmers use multi-threading instead of multiprocessing. Threads are all performed within the operating system and are coded by the programmer. On the left side of the screen, you see a single threaded process with code data files. And in the middle, you see a multi-threaded process. And if you look internals of a process, you see threads have their own registers and stacks, but share static heap and code of the process's memory. This is very important, and I think you already know those concepts from your operating system courses. And let's remember the life cycle of an instruction. You write some program, for example, in C language, in C#, in Java, in Dart, in Python, and you store your program software in the disk. Your software, your program includes instructions. You remember if, then, else, switch, blah, blah. When you instantiate your program, It has been loaded, it's loaded into RAM, random access memory. An operating system makes an abstraction and converts them to processes. One program may launch a process or more than one processes. For example, Chrome browser. When you instantiate a Chrome browser software, it may launch more than one processes. And since every process at least have one main thread, threads starts to live. An operating system has a scheduler giving execution time, making context switching, selecting them according to their priorities, and making preemption to execute. The CPU may be single core or quad core. This is another topic we will discuss later. Concurrent programming uses a single thread to execute multiple tasks in an interleaved fashion. This is different from parallel programming, where multiple tasks can be executed at the really same time. For example, on a multi-core processor. Parallelism is the simultaneous execution of multiple pieces of work in order to increase speed. Parallelism means concurrency, but every concurrency may not be a parallelism. Parallelism is another way of concurrency. You can see in the picture on the left, there is a single CPU, single core CPU with one thread. We are executing different tasks. But on the second picture on the right, we have two cores. Two cores. We are making a parallel processing. For example, P1 and P2 are executed on the same time, really same time. So they are both concurrent and parallel. When we are saying parallel, we need to think about more than one course physically. Let's look at some history. Since we pay too much money to the CPUs, we want to utilize them. We want to use them. So in the old days of programming, programmers, people started to look for the ways to utilize the processors. This is the birth of concurrency topic, actually. One of the first approach was multiprocessing. Multiprocessing is maybe the first design to appear historically for concurrency. There are some other issues, topics, maybe you need to examine by yourself. You need to read by old books like time sharing, batch processing, blah, blah. But multiprocessing is the oldest, one of the oldest design appear historically. In multiprocessing, a daemon forks a new process for each connection request. The process is free to use blocking I/O. Non-blocking behavior is provided by operating system level context switch. What does this mean? You create extra processes, you fork extra processes to make concurrency. What are the advantages of this approach? Very simple, right? Just fork another process. And also when your process crashes or experience some resource exhaustion, there is no effect, there is no impact on neighbor processes. But what are the cons? Processes are heavyweight structures for CPU and memory footprint. And also, if you need inter-process communications, it is very difficult to implement this. Another possible approach appeared as multithreading. Multithreading uses threads in much the same way that multiprocessing uses processes. What is the advantage? Because threads are lighter weight than processes, a much larger number of them can be executed concurrently. Another disadvantage, if a thread crashes, it crashes the entire process and all of the threads in it. They are the disadvantages. So, as a summary, we can say that both multithreading and asynchronous programming are different forms of concurrency. However, they both have their own special uses. On the diagram, you can see threading synchronous and threading asynchronous. A single thread, synchronous, multithread, synchronous, single thread asynchronous, multithread asynchronous. I will give you an homework. Maybe you remember in your math courses, there is Taylor series. I want you to think about it, how I can implement Taylor series in a parallel and asynchronous way. This will be very useful for you. Synchronous and asynchronous are also known as async and sync. Shortly, are two types of programming models. Programming models on abstract level means how software is designed and executed. Programming model is an execution model coupled to an API or a particular pattern of code, like Spark on Java or Hadoop's MapReduce. When you write some code in synchronous manner, it may take too long time. For example, on the screen you see 45 seconds. If you implement it in asynchronous way, it may take 20 seconds. Knowing how these two models differ is also very useful for you when building your APIs, creating event-based architectures, and considering how to handle low-running tasks. The most important issue for asynchronous programming is that it relies on a non-blocking input and output protocol. In synchronous way, you make a request, wait for response, finish, another request, another response. In asynchronous manner, you make your request, it is asynchronous, you may not continue your business.
Gireceğim şimdi.
Software development in software
Yok, not aldım, gireceğim şimdi.
called as loose coupling. Loose couple communications and or programming allows for decentralized processes. And this means higher fault tolerance and increased flexibility. And this is real-time example. You want to cook some eggs and you want to cook the toast. In synchronous manner, you cook the eggs and then you cook the toast. If you want asynchronous single-threaded, you start the eggs cooking and set a timer. You start the toast cooking and set a timer. While they are both cooking, you clean the kitchen. When the timers go off, you take the eggs off the heat and the toast out of the toaster and serve them. In asynchronous multi-threaded, you hire two more cooks, one to cook eggs and one to cook toast. Now you have the problem of coordinating, like inter-process communication issue, the cooks so that they do not conflict with each other in the kitchen when sharing resources. And you have to pay them. Now, does it make sense that multi-threading is only one kind of asynchrony? Please have a look on the animated GIF. In asynchronous manner, you need to wait the previous task to finish, but the third one, asynchronous code, it finishes later. The most important sentence in this slide is threading is about workers, asynchrony is about tasks. And some technical examples in your business life, in your computing life. For synchronous processing, user interfaces when you expect some input from human beings. And communicating with HTTP APIs are good examples. Asynchronous processing, batch processing, and I/O blocking long-running tasks are good examples for that for your daily computing life. What are pros of advantage of asynchronous programming? User experience. When you write asynchronous programs, your page, your software, your user interface becomes more responsive. Why? For example, you have many interactions on your website or your mobile application. If one of the items, features cannot get response, you may continue to load the page. Customization, since you are making callback functions, since we are using callback functions, programmers may customize the software according to the return codes, according to the error codes. And since async await is a well-known syntax structure of many programming languages, our codes is more scalable. What are the disadvantages of asynchronous programming? Knowing asynchronous programming is a bit difficult, and our codes may become complex. And rendering asynchronous code is a bit difficult, so page rendering may cause some latency. And since not every programming language support or has a good implementation of asynchronous programming, maybe we can experience some difficulties in compatibility. This is a very, very good meme I have found in internet. In the old days of JavaScript in ES5 version, JavaScript coders always using callbacks, and that was causing a great complexity. In ES6, promises emerged, and this became a good, very good news for JavaScript developers. And now with async await syntactic sugar, JavaScript programmers are in their heaven days or their asynchronous programming experience. Today, I have chosen the Dart language to make some practice in asynchronous programming. Why I have chosen Dart? Because I know nowadays not lots of the guys, lots of the programmers know Python language or Java language. And since you know already Python or Java, to better understand the implementation and the level of abstraction of asynchronous programming, another language, examining another language, working on another language may be better for you. That has asynchronous programming functionalities, features like futures, async and await, are full of functions that return future or stream objects, future for single items, stream for many items. And async and await keywords also support internally from scratch asynchronous programming. Before going into code lab, I want you to give you an example of blocking synchronous code and asynchronous non-blocking code. In the first one, in synchronous blocking code, function A executed, function B executed. Function C requires 3, 4, and 5, so they are executed, and then function C and D executed. But on the right side, in asynchronous non-blocking code, function A executed, function B executed, function C is asynchronous, function D is executed and the callbacks in function C 4, 5, and 6 executed. Thanks to promises, function C implements asynchronous programming, implements futures, implements async await to produce asynchronous non-blocking code.
Now let's dig into what really makes async code possible, the event loop. Imagine the life of an app stretched out on a timeline. Here you start, there you stop, and in between there are all these little events like I/O from the disk or finger taps from the user, all kinds of stuff. Your app can't predict when these events will happen or in what order, and it has to handle all of them with a single thread that never blocks. So it runs an event loop. Simple as can be. It grabs the oldest event from the event queue, processes it, goes back for the next one, processes that one, and so on until the event queue is empty. The whole time the app is running, if you're tapping on the screen, things are downloading, a timer goes off, that event loop is just going around and around, processing those events one at a time. Whenever there's a break in the action, the thread just kind of hangs out, waiting for the next event. It could trigger the garbage collector, get some coffee, whatever. All of the high-level APIs we're used to for asynchronous programming, futures, streams, async and await, they're all built on and around this simple loop. For example, say you have a button that initiates a network request, like this one. You run your app and Flutter builds the button and puts it on screen. Then it waits. The event loop just sort of idles, waiting for the next thing to process. Other events not related to the button might come in and get handled. Well, the button just sits there, waiting for the user to tap on it. Eventually they do, and a tap event enters the queue. That event gets picked up for processing. Flutter looks at it, and the rendering system says, hey, those coordinates match the raised button. So Flutter executes the onPressed function. That code initiates a network request, which returns a future, and registers a completion handler for the future by using then. And that's it. The loop is finished processing that tap event, and it's discarded. Now, onPressed was a property on raised button, and here we're talking about a callback for a future. But both of those techniques are doing basically the same thing. They're both a way to tell Flutter, hey, later on, you might see a particular type of event come in. When you do, please execute this piece of code. onPressed is waiting for a tap, and the future is waiting for network data. But from Dart's perspective, those are both just events in the queue. And that's how asynchronous coding works in Dart. Futures, streams, async and await, these APIs are all just ways for you to tell Dart's event loop, here's some code, please run it later. If we look back at the code example, you can now see exactly how it's broken up into blocks for particular events. There's the initial build, the tap event, and the network response event. Once you get used to working with async code, you'll start recognizing these patterns all over the place. And understanding the event loop is going to help as we move on to the higher level API.
Evet, bu videoda, the Flutter team member introduced us how Dart code implements asynchronous code, how event loop executes your code in a single thread. Dart is a programming language designed for client development and is used for Flutter cross-platform framework. Flutter nowadays are very popular because you can write iOS, Android, native Linux, Windows, macOS applications on a single code base. And since it's not using some bridging technology like JavaScript bridge, it's totally native and performance is very good. It can also support 120 frames per second user experience. Before going to code lab, there is another homework for you. I want you to understand and learn how Python implements asynchronous programming. And also, since this is just an introduction for asynchronous programming, nowadays there are lots of other discussions, there are other hot topics on concurrency and parallelism concepts. There's a good document. Please have a read, please have a look to that document, and you will find many new topics, very hot topics on concurrency and parallelism concepts like fibers, generators, coroutines, green threads. So let's make some
Now let's dig into what really
coding. Now I will open a web page. This is Dartpad. You can write interactive codes in Dartlab. I think I need to share also my browser page. Just a minute. Stop share. New share. Asynchronous programming. Yes, share. Here we go. Let's remember why asynchronous code matters, when asynchronous code matters, fetching data over a network, for example, writing to a database, reading data from a file, meaning I/O blocking operations. This is Dart language. Don't worry, it is C style, very easy language. I highly suggest you, I highly recommend you to learn this language. Here, a code example, main program body. This is a function called fetch user order and print statement fetching user order. Here you can see a future statement. Future is a contract, is a promise in asynchronous programming. You are saying, hey, give me a promise. You will return me. So there are two status for future type. No response, a response. A response may include an error code or the response itself. So future type may be generics, any type. Here is void, but it can be a big T, any type. Future can execute, can implement any other sub-functions like delayed, then, kind of. Here we use delayed to create a sample 2 seconds delay. Let's execute our code. Fetching user order. After 2 seconds, large latte. This is sample, this is the same sample with an error message. Remember, there are 2 cases for a future, no return, and a return, maybe including an error. Here, we got an uncaught error exception. Let's inspect this code. Here, the main statement. If you implement await keyword for asynchronous programs, the function must be async itself. So you need to add async keyword to the function body. Count seconds function with an argument 4 and await asynchronous call to print order message. Let's execute this. And See what will happen. Please note the difference. After 4 seconds, we got our order, large latte. Why? Because our future also here, you see, waits 4 seconds. Let's make this 8 seconds and see the difference. Here you see, after 4 seconds, our order is here. In Dart language, future are just for one, let's say, object or item. It may be string, integer, blah, blah, any type. If you expect more than one item, you need to use streams. Future is one for item, stream is for more than item, maybe any type. And by using the future function, you can use the then implementation, future.then, future.then. This means when future is implemented, returned some value, you may execute the software code you have written. But since we can implement many thens consecutively, this may cause complex programs. So that's why most of the programming language implements async await pattern. Async await is just a syntactic sugar to write asynchronous code looks like synchronous code. I want to give an example. There's a good medium document. I just want to share this to you. Just a minute, guys. I am not a full-time lecturer, so please forgive me. I think this one. Yes. Here you see very basic synchronous code. Everything is synchronous. Start, hello, and end. Here you can see a future implementation returning an instance of future string. Remember, a future has 2 possible states, uncompleted, completed, either with a value or with an error. What's a callback? Here, as I said you before, an async code, async functions like, for example, in here, greetings can implement then, can use then. Like delayed, remember. But when we implement many consecutive or complex then, like here, it becomes more complicated. People call this as callback hell. Callback hell is very difficult to write, understand, debug. So the most important feature for a programmer to write understandable codes. This is very good. So your code must be understandable, maintainable. Async await here is a syntactic sugar to make your asynchronous code looks like synchronous code. Now you can see here, we implement async await and code is very clear, debuggable, understandable, maintainable. All right. Okay. Thank you very much listening to me. Sorry for any inconvenience if you experience, because as I said, I am not a professional full-time lecturer. I'm just a guest lecturer to serve my experience voluntarily for you, our future colleagues. If you have any questions, please do not hesitate to ask me. I will try to answer your questions. Yes, any questions? Syed Mohammed Hamza, thank you for your comment. What's your question? Would you please turn on your cameras also? I want to see your smiling faces also. Any questions? Ahmet Muaz, Şimal, Alpay, Ayşe, Berkay, Cankat, Harun, Ertan, Mehmet, Mert, Mustafa, Sena, Umut, Zeynep. Bu dersi iyi anladıysanız ömür boyu sizin için güzel olacak. If you understood the course, this will save your life, because the topics are very important in computing business for your future programming life. Very funny question from Syed Mohammed Hamza. It may off topic, but I really want to ask, did go to and jump instructions really help you in programming? Very good question, very funny question. Mohammed, historically, by historical point of view, when you go to old days of microprogramming, the early days of microprocessors like Intel's 80 series or Motorola series, people were writing codes in assembly language. So those were very near to the instruction sets of the CPU. So those kind of go to jump kind of statements, phrases come from those understanding, because subrouting concept, for example, was invented just to prevent repeatedly typing the same codes. So go-tos and jumps saved our lives in the early days of our programming, but was always considered a bad programming practice. Especially after object-oriented paradigm, go-to and jump were terrible even to talk about. Thank you for very good question. I am very happy to hear that kind of questions from a young guy like you. Thank you so much. Any other questions? Don't hesitate to ask questions, please. If you ask, you learn more. If you ask, you learn more. If you learn, you ask more. All right then. Asenkron çalışan programlama dilleri için multithread çalışıyor diyebilir miyiz? Ertan, thank you for your question, but would you please ask this question in English? English is not my native language. My English is not perfect, but I am trying to improve it. But there is a, quote, how to say, practice makes perfect. If you don't talk, if you don't make practice, you cannot be perfect. So please write in English, but I will try to translate your question. Can we consider asynchronous programming language as running in multi-threaded fashion? Yes, as I told in my slides, multi-threading is another topic than asynchronity. You can write an async code in a single thread. You can write your code in multi-thread asynchronously. So asynchronity and multi-threading are different concepts. An asynchronous code may be running in a single thread. So we cannot say that every asynchronous code, every asynchronous program is in a multi-thread fashion. Answer is no. Thank you, Ertan. Thank you, Ertan. Thank you so much. Any other questions? I hope you really understood the topics: concurrency, multi-threading, parallelism, asynchronous programming, synchronous programming, what is process, what is thread, what is multiprocessing, what is multi-threading. There are two difficult topics to discuss maybe later in your next years, like distributed computing, but I'm not talking about it yet, not to confuse you too much. But asynchronous programming is very, very important topic. When you go to industry to work to make some business, without knowing asynchronous programming, it's very difficult to have a good life. Trust me. All right, then. Thank you for giving me this chance. I was really very, very, very happy to be with you, to share my experience with you. I hope we can meet, if you like,